In this lecture, we are going to expose you to the idea that even in the C++20 range libraries, we have a bunch of constrained iterator pair algorithms. So far, we have seen that the STL is made up of three components. We have containers, algorithms, and iterators. And we are really learning about range algorithms in this chapter here. We already know that we have two parts. We have legacy algorithms that work on iterator pairs. We also have range algorithms that work on a range directly. We have seen a bunch of these in the last lecture, I think. And we had a chance to look at a few examples of these things. We have non-constrained iterator pair algorithms in which you have to specify the beginning and end. This is an example for the all of algorithm here. We also have another example here that works on the ranges all of algorithm, which is going to be working on a full range. This is the example here. And we have seen a bunch of these examples. This is the for each algorithm, which works on a range. Again, notice that it is living in the std ranges namespace. Here is the sorting algorithm, which is going to be working on a range as well. You can see that right here. We have the find algorithm. We can even use the copy algorithm and copy into an output stream iterator, just like you see here. Again, this is going to be working on a range. But one thing I really want to bring to your attention is that even in the std ranges namespace, we can use iterator pairs. So for example, we can do something like this. We can use the all of algorithm, and that's going to be coming from the std ranges namespace. But notice that we are using beginning and end iterators. We can specify this. We can do the same for a bunch of algorithms. For example, we have the for each algorithm here. We have the beginning and end iterator. We have the sort algorithm. We have the beginning and end iterator. We have the find algorithm here. And again, we can specify the beginning and end iterator while using the std ranges namespace to make these things work. And you might be asking, why do we have the same thing that we have in the std namespace in the std ranges namespace? Well, the std ranges versions of iterator pair algorithms are constrained with concepts. And starting in C++20, I would really recommend using them because they are going to give you better error messages if you happen to be passing wrong iterators to algorithms. And we're going to look at a simple example when we hit Visual Studio Code in a minute. For example, here we have an innocent CMang piece of code. We have a list. We're going to print it. We're going to try and sort it. And when we hit this point, things are going to blow up in our face. And I would challenge you to try and figure out what is going on here. But if you can't figure this out, please bear with me. We're going to head over to Visual Studio Code, and we're going to see that the ranges version of the sorting algorithm using the beginning and end iterators is even going to give us hints on what we might have done wrong. So without waiting anymore, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is ranges library iterator pair algorithms. We're going to grab our template files pretty quick and put them in place. And then we're going to crack this open in Visual Studio Code by dragging and dropping here. This is going to give us our project. We're going to trust the folder here, no problem. And we're going to open this up. We're going to take out what we don't need here, like we always do, and we're going to include the ranges header. I think we need that. And we're going to include concepts in case we need this here. We are also going to include a bunch of headers. One we're going to need is list. Let's say list properly. We're going to need vector, and we're going to need algorithm. And after this, we're going to put in our function, which is going to be printing collection here. This is a templated function, which is going to be printing any collection that supports this syntax that we have here. So all that is needed is something that supports the range-based for loop that we are using here. We're going to be looping through the collection, printing out each element, and at the end, we're going to close with this square bracket here. We are going to start by playing with the all of algorithm here. So we're going to put in some code. Let's say that we are using the all of algorithm, and we're going to be targeting all the numbers that satisfy this predicate that we have here. So we can use the all of algorithm. We're going to specify the beginning iterator, the end iterator, and we're going to be printing what we find out here. So we're going to know if all elements are odd or if not all elements are odd. And what I want you to notice is that we are using the algorithm in the ranges namespace. That's what we see here. But we are using an iterator pair, specifying the beginning iterator and the end iterator here. And this is going to work. I want you to see that this is going to work. So let's pass this through the compiler. So we're going to use GCC, but you can use any of the other compilers we have available. We're going to see that the build is good now, and we can bring up a terminal window, a new one. And if we clear and run Rooster, we're going to see that not all elements in our collection are odd because we have some even numbers. This is something you can do. We can also use the for each algorithm. Let's put in a simple example here. So we're going to be going through the collection and multiplying each thing we find by 2. And after that, we're going to print the collection. We can also sort the collection, and we're going to see what we find out here. Let's pass this through the collection, but before we do, please notice that we are using the ranges version of the algorithm, and we are specifying a beginning and end iterator, and we are passing in this predicate here. This is going to work. Let's pass this through the compiler. We're going to use GCC as always. The build is going to be good. We can clear and run Rooster. And if we use the for each algorithm, you're going to see that we have multiplied each element by 2. And after that, we're going to sort our elements, and you're going to see that this is going to work really well. This is cool. Again, we are using the ranges version of the algorithms, but we're not specifying a range. We are specifying an iterator pair. This is what I want you to see. We can also look at another example. In this case, we're going to be looking at the find algorithm. We're going to be finding if our collection contains odd elements, and we can use our algorithm like this. I think we can do something like this. So we can use the ranges version of the algorithm, and we're going to specify an iterator pair. We're not going to specify a range like we did in the last lecture, and this is going to work. We're going to pass this through our GCC compiler. The build is going to be good, and if we run Rooster, we're going to see that numbers does not contain any odd number because everything is even here. You can see that right here in the numbers that we have inside. Let's go down and do another simple example. In this case, we're going to be copying to the output stream using the copy algorithm and our iterator adapter here. So we're going to specify that we want to use the ranges version of the algorithm, and we're going to specify the beginning and end, and we're going to specify the output iterator, which is going to forward the data in our output stream here. This is going to work. Let's pass this through the compiler. We're going to use GCC as always. And if we clear and run Rooster, we're going to see that we are printing our data here through our copy that we are doing in our output stream iterator. Now, you must be asking, why provide copies of these algorithms? We have these algorithms in the std namespace. For example, if we want, we can take out this ranges thing altogether, and this is going to work for the last example here. Let's pass this through the compiler. Okay, this is going to build just fine. Why provide the same thing in the ranges namespace? Well, the thing is, the algorithms in the ranges namespace are constrained using concepts. Another benefit is that in some of these algorithms, you're going to have projections. If we look for algorithms in C++, let's do C++ algorithms. So we have the algorithms library in C++. And if we go down, we're going to see that we have a bunch of algorithms. And for all these algorithms, we have a C++ 11 version, which is not going to be constrained or using concepts to make things much easy. But we will also have ranges versions for these algorithms. And what I really want you to see is that for the ranges versions for these algorithms, we're going to have the option to specify a beginning and end iterator, but we can also specify a projection to make this much easier to use. So starting now, I would really recommend using the ranges versions. Even if you think you're not going to be using ranges, you're going to be using iterator pairs, the algorithms in the std ranges namespace are going to make things much safer to use. And I am going to give you a simple example. So suppose we have a simple list here and we're going to print it out, and this is going to work exactly like it should. Don't we have something called numbers on top? Let's make sure. So this is our numbers list. Let's call this numbers 1 or numbers list. Let's call this list explicitly. And we're going to print this out. We're going to say stdc out numbers list. And we're going to see what happens here. Let's pass this through our compiler. The build should be good. So let's clear and run roster. And we're going to see our numbers list here. This is working just fine. This is coming from our list that we set up at the end of our file here, the list right here. But some of you might try and do something like this. We are going to use the non-ranges version of the algorithm. So we're going to say std sort. We want to sort our list. We're going to pass in a begin iterator and an end iterator. And some of you might think this is going to work. Let's try this out with our compiler. We're going to pass this through the GCC compiler. And we will try to sort numbers list. That's what we want to do here. So let's do list and list here to make sure we have the compiler error. I want you to see, you see that the moment we try to do this, it's going to look like nothing is wrong here. But let's pass this through the compiler. We're going to use GCC and things are going to blow up in our face. Trying to sift through this madness to try and figure out what is going wrong here. My bet is most of you are not going to be able to figure out what is going wrong, especially if you are beginning with these things. So the problem here is that we are trying to use a sort algorithm which really expects a random access iterator, but we are using iterators we get from list, which doesn't provide random access iterators. std list only provides bidirectional iterators. So this is going to blow up in our face, and we want to be able to really find out what is going wrong here. But if we use the ranges version, so let's do that. At list, this is going to be constrained using concepts, and we're going to have a concept failure, which is probably going to give us more information on what might be going wrong here. So now that we are using the ranges version, we're going to try and compile this. We're going to use GCC again. And if we sift through this, we are probably going to get a bunch of concept failures. So let's go through this. This is not easy to sift through. This is what you get with template programming. But if we go down here, we have something about ranges here, which is really not useful. We see that we have some constraints that are not satisfied. This is a good thing. And if we go down at list, we're going to see that we require a random access range. And because we are using a list which only provides bidirectional iterators, these bidirectional iterators can't be used to set up a random access range. Hopefully, this is giving us some hints on what is going wrong here. Again, to be honest, these errors are not clear enough. Hopefully, in the future, we're going to see errors that say that you need a random access iterator to make this work. And if we go on top, you see that we even have that here. So my bad here. I didn't really find this. You see, we require a random access iterator for this to work. And now we know that we are using the wrong container to work with our sorting algorithm here. And we can fix the problem by using a container that provides random access iterators if we really want to use the sort algorithm here. A good example is std vector. So we're going to put this in. And the moment we do that, we're going to see that this is going to work. Let's pass this through the compiler and see that everything is right now. You see the build is good. And this is really going to work. If you want, you can print this out. It's going to be sorted. This is really all I wanted you to see in this lecture, that you can use the ranges versions of these algorithms. And I really recommend using the ranges version because, for one, they are constrained with concepts, but they also allow you to use projections if you happen to need them in your C++ programs. And if you don't know about projections, don't worry, that's what we're going to learn about in the next lecture. but they are a cool thing you can use in your C++ program. So we are going to stop here in this lecture and head to the next one and learn about projections. Go ahead and finish up here and meet me there.